Hello everyone, we're going to do a couple of physics problems tonight. They will be separate videos just simply because of time constraints that YouTube places upon me. Our first one's going to be a ladder against a wall. Okay, and reading it, and again, in most cases, the problems will be Google Docs. If you read the video description, you'll find a link to the Google Doc. So you can print this before you go through the video with me. A ladder with a length of 7 meters and a mass of 30 kilograms is leaning against a wall at a 53-degree angle. Where the ladder joins the wall, there is no friction. However, there is friction between the ladder and the floor. Find the force of contact between the ladder and the wall, along with the coefficient of friction for the ladder and the floor. So if we draw a picture of this, we have a ladder on our wall. It's making a 53-degree angle right here. Its length is 7 meters. And its mass is 30 kilograms. Now the problem doesn't say it, but we're going to assume a uniform mass throughout the length of the ladder. Okay? And yeah, that would be a good way to start. Now, the first step in a problem like this is a free body. Okay? So step one is a free body. And we're just drawing a free body of the ladder. Okay? So I get to draw it like this. Now the forces on our ladder is the force at the wall. So I have the wall force. We have the normal force down here, where the floor is pushing up on the ladder. Now the ladder wants to move to the right, so friction will be going back to the left. There's basically my free body missing one thing. What am I missing? The weight of the ladder. Okay, and the weight of the ladder is 30 times 9.8, and we have our nifty calculator right here. And I'm using one of the older 84s because I got a bigger screen and it's easier for everyone to see what I'm doing. So we do 9.8 times 30, and the weight of the ladder is 294. Next thing we do is components, but there's no angles on my forces, so I don't need components there. Okay? Now, the third step is torque. So I'm going to have to go through and do my torques. But in order to do my torques, I have to decide where I'm doing the torques. The typical rule for torques is torques are summed at, probably misspelled sum, isn't that great on YouTube, point with largest number unknowns. What happens to be this point right here, because I don't know the force of friction, I don't know this one, I don't know this one. And the reason you do that is torque is force times radius. Torque is a force that causes it to rotate. Okay? Well, there is no radius, the force passes through the rotation point. That force can't cause it to rotate. So these two won't have a torque, while these two will. We know this one's 294, we don't know that one, so this will allow us to find this one. Okay? So the torque equation is going to allow us to find one of them. And remember, counterclockwise torque is positive. Clockwise is negative, and that comes from right-hand rule, righty-tighty, loosey-lefty. If you've ever done any car repair or worked with any machine bolts or anything like that, that's just how it's said, righty-tighty, lefty-loosey. Okay, it's actually this rule. We're not going to get into that right now. So what I'm going to do is redraw this free body a little bit because it's too small up there. Now that I know where my pivot point is, I have to measure all my distances from this pivot point. Okay. So all my distances have to be measured from that pivot point. We know the length of the ladder, we know this length here is 7 meters. That means the weight of the ladder would be acting at the center, 3.5 meters. Okay? Now I need all my distances from this pivot point. So I'm going to need this distance here and this distance here. I want my distances to be perpendicular to my forces, because that way they cause rotation. Now, my angle over here is 53 degrees, so this one over here is going to be 7 sine 53. So that distance over there, 7 sine 53, is 5.6. This one right here will be 3.5 cosine 53. So 3.5 cosine 53. That comes out to 2.1. Okay? And this is because this distance here is for the weight, and it's halfway across the beam. That's why this is 3.5. This force up here is all along the whole beam, so this is 7, because the length along the beam is 7. So I got my distances calculated. I've got my free body drawn, so now I can actually do torques. Now when I go do the torques on this thing, it's not going to rotate. We don't want ladders rotating. So when I sum my torques, that's got to be 0. Okay? And what I'm going to do is work my way along the beam and sum my torques. These two won't have torques because they pass through this point. So this one right here, it's going to be the one that has the torque. Okay? So if I hold my pencil at my pivot point and I push it the way that force is going, that's causing a counterclockwise rotation. Again, this force is causing counterclockwise. You can see it's making my pen move counterclockwise. Counterclockwise is positive, so it'll be positive. The force is the 294. Remember, mg was 294 way back up here. So it's 294 times my radius of 2.1. Okay? Now, the force at the wall is pushing it this way. That is clockwise. That is a clockwise rotation, so that'll be negative. Okay? We're going to put negative. I've labeled that force wall, and its distance is 5.6. Now, since this equals 0, I can move the wall across the equal sign. So 5.6 wall will equal 294 times 2.1. So I'm going to do 294 times 2.1. And I get 617.4. So I can find the force at the wall. Okay? So we're going to take and divide that by 5.6. And I get 110.25. So that gives me this force right here. And again, there's no vertical force because there's no friction. There's nothing keeping the ladder from sliding up and down. The only thing that keeps the ladder from sliding is friction here, which I drew incorrectly. Should have been this way. It's correct over here, however. Okay? So now that I've got that done, step 4 is some of the forces in the y direction. That's usually MA equals up minus down. Okay, now this thing is not moving up or down, so it'll be 0 equals. Going up, I have my normal force. And going down, I have mg. So this tells me my normal force is equal to mg, which is equal to 294. Then I do sum of the forces in the x. That's ma equals right minus left. That'd be step 5. Okay, it's not moving right or left, so it'll be 0 equals. To the right, I have the force of the wall. To the left, I have friction. So basically, friction is equal to the wall. The force of the wall, which the force of the wall was 110.25. And remember, step 6, friction is equal to coefficient of friction times normal. Okay, so 110.5 is equal to mu times 294. So I'm going to get mu is 110.5 divided by 294. So we take our calculator, we're going to divide that by 294. And we find our coefficient of friction is 0.375. Alright, so there's our coefficient of friction. There's the force the ladder exerts on the wall. Hope you find this helpful in your life. If you like the video, subscribe. I don't know how fast I'm going to be putting up these kind of videos, because right now I'm kind of concentrating on how to use the calculator, but these are going to show up occasionally. Sooner or later, there'll be a huge bank of these kind of problems. So, hope you enjoyed. Next is another one, but this time it'll be energy with a rolling cylinder.